And we are live. Welcome to Supercharged Math. This is Doug. This is a one video review. I'm calling it Arithmetic Review. It's being done to make sure students are ready for a year of math that's coming up. The units in this year of math start with fractions, then decimals, and then percent. So we get into fractions, and when we get into fractions, we have to know that we have to know our basics. So there are certain arithmetic basics which are going to be reviewed. The students will have done this already. Addition, subtraction, multiplication, division, the multiplication tables, factors, multiples. These concepts I'm going to go through in the next hour, and we're going to make sure that we feel comfortable with them. So, because what that will mean is that when we start working with fractions, we can focus on what's new in the material, which is the fractions themselves. And these other things like adding and subtracting are just steps that we do along the way. If you realize that you already know everything that I'm talking about, well, that's just good news. You are ready. If there's the occasional detail that I am covering that you realize that you don't know very well, well, that just is an indicator that it's something to work on, something to focus a bit of attention on before you get into that fractions unit. Okay, so the first thing we're going to do is addition. And it is a review. It is some very basic stuff that I know the students are already good at, but we're just going to do a few problems just to make sure that we feel comfortable with it. So I'm getting into some really quick little ones. Okay, so how about this? 3 plus 2, nice easy one, the sort of addition that a lot of people are going to do in their head. You don't necessarily have to count on your fingers or have objects, 3 of this and 2 of this, and add them. You want to feel comfortable enough with the numbers that you can add these just by looking and say, okay, 3 plus 2 equals 5. We have our answer. Yes, that was a very basic one. Then we get slightly more challenging. 5 plus 9. What is it that makes this more challenging? The fact that the answer for the first question was a 1-digit number, but the answer for this question is going to be a 2-digit number because the sum of 5 and 9 is more than 10. 5 plus 9 is 14. So usually students will show the question and the answer this way in a line. Let's do another one. Slightly more challenging. 4 plus 7 plus 6. Okay, so we're still doing addition. What's new? Okay, we're adding 3 numbers instead of 2. Yes, of course we can do that. And we can do it in stages. 4 plus 7 is 11. 11 plus 6 is 17. I have my answer. I could do it in a different order if I want. It doesn't matter which number you start with when you add. So I could say 7 plus 6 is 13 and then add the 4 if I wish, and I still get the total of 17. And it's still the sort of question that we can write down in a line. I'll erase, and then I'll do the next example. Again, I'm just going from the easiest examples and taking little baby steps to slightly more challenging examples. And it's all being done just to make sure that we feel comfortable with it. Put that there. I always will be checking the time to see how much time I'm spending on each topic, because I really have about 7 topics I want to cover in this hour, and I want the video to be just about exactly an hour. How about 17 plus 32? Now we can also answer this in a line. But we have 2 2-digit numbers here. And so it becomes slightly more demanding. And that means that we can also change our approach, and we can do it with columns like this, 17 plus 32. It's the same question. And then we start practicing our real addition skills, the multiple step addition problems. 7 plus 2 is 9. 1 plus 3 is 4. We add the values in the ones column and we get our answer for the ones column. We add the values in the tens column. We get the answer for the tens column. We have our answer. 17 plus 32 is 49. If we're able to do this with the question written this way, that's great. The way I do it is I'm saying, I see 17 that's in the tens. 32 is in the 30s. 10 plus 30 is 40. And then 7 plus 2 is 9. That's one way of doing it. There are multiple strategies. You use the strategy that you feel comfortable with. Being able to do it is the thing that's important. Okay, so again, a slightly more challenging one. I'm going to erase and make room And we're going to do the same thing. We're going to try it in line and try it in columns, but slightly more challenging. Why? 41 plus 53. Is this much more challenging? I don't know if it really is. I'll write it both ways. 1 plus 3 is 4. 4 plus 5 is 9. No, it wasn't really very different from the last example. 40 plus 50 is 90. And 1 plus 3 is 4. And 90 and 4 is 94. I'm getting the same answer. I feel comfortable doing it either way. One more. Oh, okay, now let's get into some 3-digit numbers. Okay, let's do an erase. Yes, if we can add 1-digit numbers, if we can add 2-digit numbers, well, I guess we can add 3-digit numbers as well. 311 plus 426. Now, doing it in line like this becomes more and more challenging as you get larger numbers because you have to keep track of hundreds, tens, ones, and it can become easier and easier to make a mistake if you have extremely large numbers. So I really recommend doing this with columns. 311 plus 426 works the same way as the previous examples. I just have a little bit more work to do. 1 plus 6 is 7. 1 plus 2 is 3. 3 plus 4 is 7. 737 is my answer. If I'm able to do that with the question written this way, well, that's great. 300 plus 400, that's 700. 10 plus 20, that's 30. 1 plus 6, that's 7. Am I able to do this because it's an easy one? Yes. Because it is an easy one, because it didn't get very complicated, even though the numbers were large, 3-digit numbers. So let's move on to another one. We're going to go back to the 2-digit numbers now. What do I have here? Oh no, you know what? I'm going to do one more with 3-digit numbers, but I'm just going to write it in a column right to start with. 421 plus 164 plus 213. So here I am adding 3 numbers again. 3-digit numbers. It's starting to become a giant problem. 1 plus 4 is 5 plus 3 is 8. 2 plus 6 is 8 plus 1 is 9. 4 plus 1 is 5 plus 2 is 7. 798 is my answer. I'm able to do it. But I didn't have to do any carrying. And that's where it starts to get a little bit more complicated. And that's where I'm going to switch back down to 2-digit numbers again. Let's try 74 plus 19. 9 plus 4 gives me an answer that takes 2 digits. It goes into the tens. 4 plus 9 is 13. I have to write my 3, and I have to carry a 1. 7 plus 1 is 8, but now I also have to add the 1 that I carried, so I have 93 as my answer. When we try to do this with columns, we can see what we're doing. We show the number that we're carrying, and we're careful and we're able to get the answer. When we try to do it in line, it's starting to become a little bit more challenging. I can say 70 plus 10 is 80, and 4 plus 9 is 13, so I have 80 plus 13. I'm still able to do it. I'm still able to get 93, but I have to keep more things in my head in order to get the right answer. And it can be a little bit easier to see what I'm doing if I use the columns. I think a good rule of thumb would be, if you need the columns, you should be using them, if that's what it takes to keep you organized. So that was a fun one. Let's do 2 more like that involve some carrying, and I'm trying to change the examples up a little bit. So how about 62 plus 55? I need to give myself a bit more chalk. 62 plus 55. Well, this time 2 plus 5 is 7. I didn't have to carry. I got a 1-digit number. But 6 plus 5 is 11, so I have to write 11. I have to put a number into the hundreds column in order to give my answer. 62 plus 55 is more than 100. So I didn't really show myself carrying the 1 because I was getting to the end. How about 86 plus 79? 6 plus 9 is a 2-digit number. It's 15. I'm going to write 5. And then I'm carrying a 1. 8 plus 7 is 15. Plus the 1 is 16. I'm getting 165. Is that right? Yes, it is. I was able to do it. So this time I had an extra digit In both, I had to carry a 1 when I did the ones digit, and then I had that extra 1 to write when I went into the, when I added the tens digit, because I got an answer that was more than 100. So more than one thing happened at a time. And that's it for my review of addition. If you can handle problems like this, then you are ready for our units that are upcoming. Big addition questions like 86 plus 79 aren't going to happen very often in the fractions unit, but when you get to the decimals unit, you're going to need those skills. And I'm finished with my addition page, so I can put that down. Subtraction. I won't do as many examples for subtraction. It is very similar, of course. Now we're taking away numbers instead of adding numbers. So a very small subtraction question, 8 minus 3. We can do this quite quickly if we're ready. 8 minus 3 is 5. How about 12 minus 6? Not very different, except I have a 2-digit number here, so the number's a little larger, that's all. 12 minus 6 equals 6. Can I do this? How about 20 minus 5 minus 10? I have 3 numbers again. That's a little weird with subtraction. We did it with addition, we can do it with subtraction. But again, we're sort of doing it in stages. 20 minus 5 is 15, minus another 10 is 5. I'm able to do it. And I'm doing these in a line. But I can get to questions where maybe it's going to be a better idea to switch into doing the subtraction with columns. So let's do one of those. We're getting some 2-digit numbers here. 43 minus 21. I'm showing it in a line, but I can also show it with columns. How do I do this? 3 minus 1 is 2. I have my answer for the ones column. 4 minus 2 is 2. I have my answer for the tens column. Not so bad, but I didn't have to do any borrowing for this one. Let's do another one. 67, oh, well, I guess I can show the answer here. 43 minus 21 in my head, doing it in a line, that's a little bit more challenging. I know I can do it, but I think I really trust this method the best. 40 minus 20 is 20, 3 minus 1 is 2, 20 and 2 is 22. I am able to do it, but I really have to watch out with subtraction. It's a little bit more risky than addition was for answering questions in this way. I think I want to stick with the columns method. So I'll erase this one. Let's do another one. Here we have a 3-digit subtraction. 856, I'm not even going to write it in a line, minus 224. It's bigger, the numbers are bigger, but it's the same process. 6 minus 4 is 2. 5 minus 2 is 3. 8 minus 2 is 6. I have my answer. Do I like this answer? I like this answer. I think I have the right answer. But I didn't have to do any borrowing because the upper number kept on being bigger than the lower number in these ones, tens, and hundreds digits. So I haven't gotten to a very challenging one. I didn't have to do borrowing. I think I need to do a question where we do some borrowing. But yes, we can do 3-digit subtractions. And again, we're not using 3-digit subtractions very often when we're doing a fractions unit, but when we move on to the decimals unit, that's going to happen. We want to be ready. We want these skills. How about 67 minus 18? How am I doing for time? Not too bad. Okay, 7 is smaller than 8. It's happening. I have to do some borrowing. I can't do 7 minus 8 because 7 is smaller than 8. So what I can do is I can borrow a 10 from the tens column. That turns my 6 into a 5, and I'm showing that the 10 I borrowed turns my 7 into a 17. And 17 minus 8 I can do because 17 is bigger than 8. 17 minus 8 is 9. But now it's no longer 6 minus 1 when I get to the tens column. Now it's 5 minus 1, so I have 4. 49, 67 minus 18 is 49. I'm feeling good about this. I really do want to show this in the column form because it would be too easy to make a mistake if I try to do it in a line and try to do too much of it in my head. One more example. How about 843 minus 57? Okay, I have to do borrowing. 3 is smaller than 7. I'm going to have to borrow a 10 from the tens column, which is going to turn this 4 into a 3. That turns the 3 into 13, and 13 minus 7 I can do. I get 6. But now I have to do it again. 3 is smaller than 5. It's not a 4 anymore. It's a 3 here, and it's 3 is smaller than 5, so I have to borrow. I'm going to have to borrow one of the hundreds, which leaves me with 7 in the hundreds, and that's turning my 3 into a 13. 13 minus 5 is 8. I'm able to do that because 13 is bigger than 5. And now 7 minus, oh, there's nothing here. So that's like 7 minus 0. It's not 8 minus 0. The 8's not there anymore. I borrowed from it, so there's a 7 there. 7 minus 0 is 7. My answer is 786. Does that make sense to me? Yes, I think I have the right answer. I'm not going to use the calculator to check. That's enough for the subtraction. Remember, you will use these skills when you get to the decimals unit. We will use some of the more basic subtraction skills when we're in the fractions unit. And I've finished my subtraction page, so I'm going to put that aside. And now I start talking about multiplication. Well, we have had this giant multiplication table sitting here all this time, and it's there for a reason. I'm going to be spending a bit of time on multiplication. But I'm still going to start with some of the really basic multiplications that you start being able to do before you even start building a times table, multiplication table, or learning to memorize the multiplication table. Like 4 times 2. Now, we know 4 times 2, it's multiplication, and it's like a form of addition. It's like if I have a 4, and then I'm adding another 4, because I'm doing a 4 2 times. 4 plus 4 is 8. Well, 4 times 2 is also 8. I could also say it's like I'm adding 2's, but there are 4 of them. 2 plus 2 plus 2 plus 2 is 8. I'm getting the same answer. Yes, I could try to substitute addition when I'm being asked to do multiplication, but what's good is to learn some basic multiplication answers, and in fact even to memorize them. And that's what the multiplication table is for. It's time for me to get into that for a little while. These are the... Oh, I have another example. I'll do 8 times 10. Again, it's a bit of an easy one. When you have tens involved, it can help make it easy. 8 times 10 is 80. A lot of students will be able to do that before they've gotten deep into their multiplication tables, because multiplying by 10 is one of the ones that students find easier to learn at the beginning. 8 times 10 is 80. Trying to show it by showing 10 8s being added starts to become a little bit long. Or 8 10s being added together is a little bit long. It can be done that way. Multiplications can be done with additions instead. But you get to a point with larger numbers where it stops to be worth it. It starts being more worth it to be able to do multiplications just as multiplications and not to try to switch into addition. Now, one thing that I'm going to do is I'm going to take the 2 answers that I found and I'm going to put them into the multiplication table. And I want to talk about the multiplication table first. I'm going to put down these notes. I'm going to point out that I printed this morning. I'll show it to the camera. This is an empty multiplication table, a blank one, like the one I have on my chalkboard. Now, I have to admit, it was fun drawing this, but it took a while. I wanted it to be neat. I wanted all of the cells to be big enough so that on the video people would be able to see the numbers. So I used a ruler and it took a while. I think that when I'm working on something like this, I might actually want to just draw my own multiplication table instead of having a printed one. Because it could be fun to get into the lesson that you're doing, to get into the math work that you're doing, by starting off with a ruler and a pencil and some clean paper and drawing something like that. It can sort of get your head into the lesson. I like that, and if a student wants to do that, that's great. But what you can also do, or ask a parent to do, is you can find a blank multiplication table that you can print or that you can make photocopies of. And those can be very helpful. As we're working on multiplication tables, there's lots of ways to do it. You can look at a filled-in multiplication table with all the answers there and think about it and practice doing the multiplications. But I think that it's really fun to take a blank one and start filling in all the answers. What you do is you do the easy answers first. So I was doing this with my granddaughter just the other day, and she's just about going to start this as well in school. So it was fun to watch her and to see how she did it. I asked her, what is 1 times 1? I started with the easiest question in the whole multiplication table. And she did know it was 1. But then when I said 1 times 2, she said 3. She was adding. And I had to remind her, okay, wait, we're not adding, it's multiplying. What's 1 times 2? And then she got it. 1 times 2 is 2. And what the students start to notice is patterns. And that's the fun of multiplication tables, is it seems like so much. It's huge. Look at all of these answers I'm supposed to know. I don't know all of them yet. It's just too much. That's how it feels, except what you do is you find the easy ones and you start filling it in, and then you see patterns. So what's the pattern that's emerging here? 1 times 3. It's another easy one. Usually the students know the answer. 1 times 3 is 3. And we realize that in this top row, the answers keep on being the same number that's up here in the top of the table. So 1 times 4 is 4, 1 times 5 is 5, 1 times 6. And we realize actually this was rather easy. But we are filling in a big chunk of our multiplication table. And that's encouraging. I know all of these. I know 1 times a number gives that number as the answer. And then I just have to take one little leap. And I did this with my granddaughter as well. Well, wait, what about this one? I said 2 times 1. We already did 1 times 2, and we know the answer is 2. 2 times 1 is also 2. And she got that. And then we realized, hey, when we got all these easy answers and we were able to find the pattern and fill in this big chunk of the table, well, now we get to do it again. Because this first column, we're doing the same thing. We're just putting the number that's not the one first. Instead of saying 1 times 2, 1 times 3, 1 times 4, I'm saying 2 times 1, 3 times 1, 4 times 1. I'm still multiplying a number by 1. And therefore I'm getting the number as the answer. It doesn't matter which one's first. So 3 times 1 is 3, 4 times 1 is 4. I see my pattern. I'm repeating all of these values. And I know so many answers. I know another thing, which is it's hard to write this low on the chalkboard. So it'll get a little bit messy. 11 and 12. Yeah, that was a little messy. I hope it can be read. Okay, so we have filled in a whole row and a whole column just with all of the multiplications by 1. And then we start saying to ourselves, okay, what other easy ones are there? Because students have done a lot of this multiplication before they're ever shown a table. They've gotten a lot of the answers, they've gotten used to a lot of the answers, and they often will realize certain things like 2 times 2 is 4. 2 times 3 is 6. It's not that hard. We realize that we actually already know how to do it. And what's the pattern? I'm taking the number up here and I'm doubling it. I'm taking the number up here and I'm multiplying it by 2. It means the same thing. So 2 times 4 is 8. 2 times 5, that's 2 5s. That's like 5 plus 5. I can use addition if I want. 5 plus 5 is 10. 2 times 6 is like 6 plus 6. It's 12. And I see the pattern. I'm going up by 2s. I'm counting, but by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm even into the big numbers with 2 digits, and it's still not very hard. 2 times 11 is 22. 2 times 12 is 24. And anytime I realize that I understand the pattern, and I can fill in a whole row, that means I can also fill in a whole column. 3 times 2 is 6. 4 times 2 is 8. I'm doing the same thing. I'm counting up by 2s. 2, 4, 6, 8. Is the next one going to be 10? Yes, it is. 6 times 2 is 12. 7 times 2 is 14. Yes, it's getting messy. 16, 18, 20, 22. That one's messy. 24. But I managed to get them in. And now look how much of the times table I have filled in. How am I doing for time? I'm doing quite well. This takes a while. And I want to fill this whole thing in. It's starting to, the answers are starting to get bigger. It's starting to be a little bit more challenging. One strategy I can use is to find another easy section to do. And I can think back to this. 8 times 10 was 80. When we multiply a number by 10, we take that number and we put a 0 after it. And that is one of the easy ones. And students, even though 10s are big, students are able to do the 10s section of the timetable quite early on. So let's get into the 10s. I'll do it over here. 3 times 10 is 30. 4 times 10, I have to show you, 4 times 10 is 40. 5 times 10 is 50. I see my pattern. I'm taking the number that's here and I'm writing it with a 0 after it. So therefore 6 times 10 is 60. 7 times 10 is 70. Or I can say I'm counting up by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I even have a 3-digit number as an answer and I'm still able to do it. 110, that's a little more tricky. 120. The 11 already has 2 digits, but I write it and I put a 0 after it. 11 times 10 is 110. Not so hard. And then of course, because I was able to do a whole column, I can do a whole row as well. 10 times 3, 30. I'm using the pattern. 10 times 4 is 40. 50 for 10 times 5. 60 for 10 times 6. 10 times 7 is 70. 10 times 8 is 80. 10 times 9 is 90. 10 times 11 is 110. 10 times 12 is 120. I can do it even with these 3-digit answers. And now look how much of the times table is filled in. This is good. I'm feeling confident, and that's how I want the students to be able to feel. Now, if you already learned your entire multiplication table, you think this whole thing is easy, but I bet you can still see that it's fun. And it's fun to see the patterns emerging. Here's an interesting pattern. Here we have a 1. Here we have a 2 and a 2. I'm going diagonally. Here we have 3, 4, 3. And here we have 4, 6, 6, 4. There's all sorts of patterns that jump out at you from the multiplication table. But what's another easy one to do next so that we can fill in a little bit more? The 5s. 5's kind of easy because, of course, you know, we have 5 fingers and we learned 5s and with most money we have the nickel, we have the 5-cent piece. So we get good with 5s earlier than with some of the other numbers. So let's count up by 5. So we have 5, 10. What's after that? If you're counting by 5s, it's 15. And we just gave an answer to 5 times 3 is 15. 5 times 4, that's 20. 5 times 5, 5 times 6. Takes a little bit more work than the 10s. It's a little bit more work than the 1s and the 2s, but we can do it. And then we see, wow, that's an interesting pattern. 5, then a number that ends in 0, then a number that ends in 5, and then ends in 0, it's going 5, 0, 5, 0, 5, 0. We see that pattern and we're able to predict. We had 20, then we had 25, we have 30, we're going to have 35. 5 times 7 is 35. Indeed it is. 40, 45, 50, 55, 60. Wow, we did the 5s row, now we have to do the 5s column. 15, 20, we knew that was going to be a 25 and it's already there. 30, 35, 40, 45, 50, 55, and 60. Yes, it's a little messy down there. I have a lot of numbers filled in. I don't have that many blank spaces left. Now, what do I want to do next? The thing is that as we get to these blank spaces, we're getting to the more challenging multiplications, the more challenging ones to learn and memorize. Are we memorizing or are we learning? The thing is, sometimes the two things go hand in hand. When you find yourself multiplying certain numbers over and over again, you get really good at it. And you get to the point where you remember the answer really well. And in fact, you can be surprised at how quickly you remember the answer. 3 times 3, 9. Oh, the threes aren't so bad. I'm counting up by 3s. 3, 6, 9. The next one's going to be 12. 3, 6, 9, 12, 15. It's like adding, but multiplication, I think, can be a little easier than adding. 3 times 6 is 18. Then you get into some of the stranger ones. Some of the students will take a little longer to remember that 3 times 7 is 21. 3 times 8 is 24. I'm starting to talk a little bit more slowly. I don't want to go too fast. 3 times 9, 27. A bit of a weird number when you're new to numbers. 3 times 11, 33. 3 times 12, 36. Not too hard, but it takes a bit more work, a bit more getting used to than some of the easier stuff we did already. But because I did a row of 3s, I can do a column of 3s, and I find myself looking at the patterns. 7 times 3, there's my 21. 8 times 3, 24. 9 times 3, 27. 11 times 3, 33. 12 times 3, 36. We have a lot of this filled in. What about the 11s? The 11s are kind of easy too, because look at the answers, look at the pattern. Now that we've done so much work, we start seeing the patterns right away when we look at our multiplication table that's partly filled in. Instead of starting to put in answers and then seeing the pattern emerge, we can start finding the pattern right away. We have 11, 22, 33, what's happening? We keep on getting a double digit. We keep on getting the same digit twice. So 2 gave us 22. 2 times 11 is 22. 3 times 11 is 33. 4 times 11 is going to be 44. We see the pattern emerging and we understand why it's emerging. 66, 77, 88, 99, and then it gets a little weird because what's 11 times 11? Not the same pattern. The pattern worked all the way down there until we hit 3-digit numbers, and then suddenly it's not working as well. Do I want to jump into that? It's up to me. It's up to the student. If you feel ready to do 11 times 11, then you go right ahead and you do it. If you don't feel ready, you say, okay, well, I did the 11s all the way down to there. I'm going to do the 11s across all the way to there as well. So we have 44. Ooh, that's messy. 66, 77, 88, 99. Even though that 11 times 11 thing was a little weird, we still filled in a whole lot more of our table. There's not all that much empty space left. And I find that when I remember doing my multiplication tables, when I remember memorizing them a long time ago, I remember that I was at this stage and I actually found these big numbers easy. Instead of finishing with them last because they're so big and so hard, I actually found them easy, and I asked myself why. And the reason why is the numbers that are closer to the end of the table are easy to see. And when you look at completed multiplication tables, you see those and you see them quickly because they're near the edge. It's not so easy to see some of this stuff in the middle. It gets to be a bit of a jumble of numbers. But the stuff that's out on the edges, you can see. And that can make the 11s and the 12s not so hard to learn after all. I actually remember the moment that I realized 11 times 11 is 121. How did I get that? That's what I'm trying to remember now. Well, 11 times 10 is 110. So 11 times 11 means I'm adding one more 11. What's 110 plus 11? And then it makes sense. Yeah, 110 plus 11 would be 121. Not so bad after all. Hard to write it in this little space, but I got it. And then what about 11 times 12? It felt really the same as 11 times 11. That number, 121, at least there was that sense that it's 1, 2, 1. You have the ones on the outsides and a 2 in between. It kind of helped to make it easy to memorize. 11 times 12 is 132. Well, one way of doing that is to say, well, 121, I have to add one more 11. So it's going to be 100, and then the 20 is going to turn into a 30, and the 1 is going to turn into a 2. It's 132. And that means this one's also 132. Sorry about it being messy. That was a little weird, but it is near the edge. And I think that's what made it easy for me to memorize it, is that when I looked at my completed multiplication tables, my eye was drawn easily to those numbers around the edge, and I found myself comfortable with it. Because one thing I know for sure is that 12 times 12 is 144, and I learned that quite early on. I think because I was curious. I was thinking, where's the hardest one? Where's the biggest one? Well, it's down here in this corner. The smallest one's up here. The biggest one's up there. It is the biggest number in the answers of the table. 144. Well, it's 2 4s in a row. That kind of helps. But I just remember I learned 140. 12 times 12 is 144 before I learned the 11 times 11 or the 11 times 12. Those three came after I learned this corner one. Now, counting up by 12s to try to fill in this, trying to take advantage of that What's on the edge of the multiplication table again? 12, 24, 36. It's a little bit more challenging to count up by 12s. But 12, 24, 36, 48. Well, I see a pattern. Pattern's only so useful. I have a 1, 2, 3, 4, and then a 6. We have a 2, 4, 6, 8. Ending with 0 is like a 10, yeah. And it makes sense because, of course, if you get 10, then you carry the 1. And that's why that 4 doesn't just go to a 5, it goes to a 6 because we're carrying 1. If I think of addition, it makes sense that I go 12, 24, 36, 48, and then it's 60. And then 60 is a nice round number. It's not so hard to add 12 to it. 60 plus 12 is going to be 72. I'm adding a digit to the 10s and I'm adding 2 to the 1s. So adding a digit to the 10s here in the next one means this 7 turns into an 8, and adding 2 to a 2 means the 2 turns into a 4. And I find myself memorizing that 7 times 12 is 84. 8 times 12 is 96. 9 times 12 is a bit of a weird one, 108. So we're getting into some of the ones that take longer to remember because they aren't as easy to see, they aren't as obvious. Now I did that 12s column, I can do the 12s row. So we have the 48, the 72, the 84, the 96, there's that 108. Some of these are a little bit more challenging. Now, the good news about these remaining ones is that their answers aren't going to be as big. Some of them have to be easy. Let's think. 4 times 4. 4 times 4 is 16. Yeah, small numbers, not so hard. And then, of course, I'm counting up by 4s. Counting up by 11s or 12s can be a little bit of clutter in your head, but counting up by 4s is something that young kids who are working on their addition have done. 4 plus 4 is 8, plus another 4 is 12, plus 4 is 16, plus 4 is 20. I'm adding 4s. 20 plus 4 is 24. Then 24 plus 4 is 28. Counting up by 4s helps me to do this. 4 times 7 was 28. 32. Bit of a weird one. 4 times 8 is 32. 4 times 9 is 36. Well, if I can do the 4s across, I can do them down. So 6 times 4, 24. 28, 32, 36. And I only have this little chunk of territory in my multiplication table that I haven't done yet. The good news, of course, is there's only 16 blank spaces left. And I've done most of it. And I find most of it easy. And when I'm practicing and I look at the numbers, I'm remembering, oh yes, I'm seeing a lot of addition, of multiplications that I know the answers to. I remember them. 2 times 6 is 12. I'm starting to see that a lot of this stuff is easy and has actually been easy for me for a long time. Some students find it a little longer to get some of these. So we have 6 times 6, that's 36. That's not so bad. 6 times 7 can take a little longer to learn that it's 42. 6 times 8 is 48. For some reason, I always found that one to be easy, but I don't really know why. 6 times 9, that one, that's a 54, and that's one that I still slow down a little bit when I think of the answer. I'm counting up by 6s though. If I really had to add, I could. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30, plus 6 is 36, plus 6 is 42, plus 6 is 48, plus 6 is 54. Not so bad after all. Only 9 left. 7 times 7. Here's another one. When you're multiplying a number by itself, 7 times 7. We had 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. I realized as I'm doing this that I actually have done these ones before and I've seen them before. Maybe it's because they're fun. What's missing? 7 times 7 is 49. 8 times 8 is 64. Boy, do we use that one a lot. 9 times 9, 81. They are a little weird. They do take a little longer to learn. 8 times 7 is 56. Well, that means 7 times 8 is 56. We're getting there. 7 times 9 is 63. I did always find that one kind of easy, but I can't explain why. 9 times 7 is also 63. There's only 2 left. 9 times 8 and 8 times 9. I think 9 times 8, which is 72, may have been the last one that I memorized back when I first did this. 9 times 8 is 72, and that means 8 times 9 is 72, and I have a completed multiplication table. In my opinion, this is fun. I enjoyed it. Having the printed out ones could be very handy if I have several copies of a sheet like this, or if I really want to get my ruler and spend some time making them, and then start filling them in. And the more you fill them in, the more you find yourself just knowing the answers and plunking them down into their positions, and the less often you find yourself having to stop and think, wait, that's one of the tricky ones. That 7 times 8 and that 7 times 9, that 8 times 9, even the 6 times 7 took me a while. But in the end, I did memorize all of these, and it can be fun also to see how fast you can find the answers. The important thing is to be able to find the answer. So if you aren't able to do it really fast, you still want to be able to do it. But the more you practice this, the more you remember the answers very quickly. And that makes it easier when we get past our arithmetic review and we get into our fractions and our decimals and our percent. Especially with the fractions, this is going to come in really handy, because multiplying two numbers is a step along the way with a fractions problem. When you're learning to multiply decimals, multiplying two numbers is a step along the way. We don't have to memorize every pair of numbers that could be multiplied. They go on forever. It would be impossible to memorize all of the possible multiplications. But memorizing the first 12 by the first 12 is extremely useful, because we need to find these answers very often as we go through our career as math students. And then after all that, I'm going back to a regular multiplication. I'm going to leave this here because I think it's useful. Because what are we going to do after multiplication? Division. Well, division is kind of like the opposite of multiplication, isn't it? Just like subtraction is like the opposite of addition. So if you know a lot of answers to multiplication, then when you're working on your division, you're going to be doing the same thing backwards. The multiplication table will still be useful. Let's look at another multiplication. Where is my chalk? 12 times 3. This time though, and 12 times 3, it's one of these. We already know the answer. I know you know the answer. 12 times 3, but I'm showing it with columns, because eventually you will multiply large enough numbers that the answer is not going to be sitting in here, and you're still going to have to be able to follow the steps. 3 times 2 is 6. 3 times 1 is 3. 12 times 3 is 36. 12 times 3 is 36. And of course that means 3 times 12 is 36. I find it in two different places in my multiplication table, and it helps me verify that I did this correctly. I need to have the skill of doing this type of multiplication. Let's do one more that's just a little bigger. Will we do this one? Here it is. 14. I'll put it down. 14 times 35. Will we do this during the fractions unit? Probably not. It's kind of big to be doing that as part of a fractions question. But will we be doing it in the decimals unit that comes after fractions? Yes, we will. And we will be focusing our attention on the decimals. So we want to already know the process. So we're already working on knowing this process. And the part of this process uses this. The first thing I have to do here is take this one's digit, the 5, and multiply it by this other one's digit, the 4. 5 times 4, well, I know that's 20 because I've been working on my multiplication tables. 5 times 4 is 20, 4 times 5 is 20. Either way you say it, 5 times 4 is 20. So I'm putting a 0, and oh, I have to carry a 2. A write it there. 5 times 1 is 5, but I have to add the 2 I carried, so that's a 7. Does this make sense? 5 times 14. 14's too big for the multiplication table, but 5 times 14 is a multiplication we might find ourselves doing quite often. 5 times 14 is indeed 70. So now I have to do the next, now this multiplication, this gets long. We will be doing this during decimals. We will be reviewing it during decimals, but it is something that we should already have been trying to do. To do my tens multiplied by these, I start by putting a 0 because I'm in the tens column. I need something to show the space to move over into the tens column. 3 times 4, that's in there. 3 times 4 is 12, so I'm writing a 2, and then I'm carrying a 1, and oh, this gets a little bit confusing. You start having too many things written on your page. But I'm nearly finished. 3 times 1 is 3, plus the 1 I carried is 4. So that means 3 times 14 is 42, and it is. 30 times 14 is 420. It is. I'm finding I'm able to do rather large multiplications. I'm not memorizing these ones. Lots of steps involved. And then I have to add the answers I got from multiplying by the 1s and multiplying by the 10s. 7 plus 2 is 9, 490. 35 times 14 is 490. Yep, and it is. That's good. I'm happy. I can do this. We will get back into this. So maybe this is one of the more challenging questions in today's review. But it is the last example I'm doing of multiplication. And really, it's about this. The steps of doing this are so much easier when you remember the answers to these, when it doesn't take too long to get the answers to the little multiplications. That's where it's extremely useful to have a memorized multiplication table. Division. I'll leave the multiplication table there. I'm not going to start calling it a division table, but I can sort of use it backwards and think about it while I'm doing my divisions. 12 divided by 2. How many times does 2 fit into 12? It's a fast one, it's a little one. We should have already been doing some division. So 12 divided by 2 is 6. 36 divided by 12. 36, if it were the answer to a multiplication, what does 12 multiply to get 36? 12 multiplies by 3 to get 36. So 36 divided by 12 is 3. The answer is actually in here. We just have to do some backwards thinking. That's good. How about 84 divided by 6? This is starting to get a little too tricky to do in my head. And I can start going divisions this way. So we will have to do this. When we get into it, we're not going to do this much in the fractions unit. But when we get into the decimals unit, we're going to be coming back to doing this again, so it doesn't hurt to do a little bit of practice. How many times does 6 go into 8? Once. 6 times 1 is 6, and then I subtract. 8 minus 6 is 2. This 4 gets carried down. 6 doesn't fit into 2. I already know that. I fit the 6 into this 8 as much as I could. I got 1 6 out of it. But 6 does fit into 24, and that's another multiplication. We're doing it backwards because we're dividing. How many times does 6 fit into 24? If 24 is the answer, and it's being divided by a 6, well, it must be, 24 divided by 6 must be 4, because 4 times 6 is 24. 4 times 6 is 24. 6 times 4 is 24. There the answer is in two different places in our multiplication table. How many times does 6 fit into 24? 4 times. 6 times 4 is 24. I subtract. Is this going to fit on the video? Yes, just barely. Yes. 24 minus 24 is 0 and finished. It wasn't an especially long one, but I did it using this type of division. And being able to do this is going to become very helpful when we start working with our decimals. Division is multiplication backwards. In a way, when you get to your divisions, you've already done the work because you've done so much work with multiplication. And that's it for division. How am I doing for time? Pretty good. Okay, I wanted to talk about multiples. Multiples. Now, I'm not going to go into too much detail about multiples. I'm going to erase these divisions. I'm keeping my multiplication table there. It's going to become coming in very handy for multiples. Okay, let's think of the multiples of 6. Now, one way to show the multiples of a number, I'll write a title here. Not very big, multiples. Put a line under it. The multiples of 6. They're the answers you get when you count up by 6s. We were doing that earlier. The first multiple of 6 is 6. And then if I add another 6 to my 6, I get 12. Multiples addition comes in handy when you're thinking your way through multiples. If I add another 6 to the 12, I get 18. I add another 6 to the 18, I get 24. And what I realize, I'm not finished. The multiples of 6 go on forever. I can't give all of them. What I can do is put dot, 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 just to show that I know they keep on going. But what I realize is I'm reproducing a line from my multiplication table. 6, 12, 18, 24. 6, 12, 18, 24. It's in the 6's row or in the 6's column in the multiplication table. So if I already have learned my multiplication tables and I become comfortable with them, I find it very fast to show the multiples of a number. Let's do another one. 12. Well, I guess I couldn't ask for a harder number if you want to stick with the numbers in the multiplication table. The multiples of 12 is what you get if you're counting up by 12s. And it's a little bit weirder to be counting up by 12s. I guess you do it a lot if you work with dozens of eggs quite often, or dozens of roses perhaps. But counting up by 12s. 12, the first multiple of 12 is 12 itself. 12 plus 12 is 24. Add another 12, we get 36. And then 48, and we can do our dot, dot, dot. It goes on forever. And what have I done? I have reproduced this bottom row of the times table. If I wanted more multiples of 12, I can just keep going. After 48, we have 60, then 72, 84, 96. Even these big 3-digit numbers, 108, 120, 132, 144, they come in handy. Knowing the multiples of 12 is the same as knowing that bottom row in your multiplication table. So once you learn it, you learn two things at once. And with that comes understanding. When you think about how, oh, my multiples of 12 are the same as my answers to... When you do that, you're thinking, you're learning. That is understanding. Memorizing is useful. Knowing forever that 8 times 9 is 72, it's going to be handy. Understanding that 8 times 9 is 72, that's even more powerful. So, some other multiples. We've done a lot of this before, the multiples of 5. Counting up by 5s, it's fun. 5, 10, 15, 20, 25. It's that same pattern we talked about before where we keep on getting a number that ends at 5 and then a number that ends with 0 and then 5 and then 0. And it's easy because it's a round number. It's what we call a round number. It's easy because it's the number of fingers on your hand. Numbers of toes on your foot, although, you know, that's only helpful if you're not wearing shoes or socks. Okay, so we can find the multiples of a number very quickly because we know all these rows and columns in our times table. If we're asked to find the multiples of a number that's part of the times table, we will be able to do it. But what if I want the multiples of 20? It's counting up by 20s. It's not in there. It's not easy to find much of it in there, that's for sure. But the first one's going to be 20. And then if I add 20 to 20, it's not too difficult to get 40. I can do the multiples of 20, even though they're not a row in the times table. Okay, next, last topic before I quit for the end of the arithmetic review. And the only topic that made me decide to use colored chalk, notice my blue and red chalk up here. How hard are they to see in the video? I always avoid colored chalk because they're hard to see in videos. But I like colored chalk. It's pretty. I like using it. And I'm going to use it a little bit. How about factors? Factors is like multiples, kind of. I'm going to erase the title multiples. factors. What are factors? They're numbers that are useful in math. We need to know the factors of a number for various reasons as we move up through our math career. Factors of, I think my first example was 6 again. Factors are all the numbers that can be multiplied by something to get 6. And the way we list them is the same as listing multiples. But I have to remember, it's not multiples. I'm not going to do 6, 12, 18, 24. Not this time. What numbers multiply to give us 6? 1 is always an answer. 1 is always a factor of every other number. Because you can always say 1 times that number is that number. 1 times 6 is 6. And one of the fun things to do with factors, I call it the layers of an onion, which is, I know the first one's 1. I know the last one's going to be 6. Doesn't go on forever like multiples. So I'm going to put a comma here. Now, I leave a lot of space because I'm not necessarily sure how many I will find. But then, what can I do? After 1, what's the next number? 2. Can you multiply 2 by something to get 6? Yes. 2 times 3 is 6. So that means 2 is a factor of 6. And so is 3. And I actually have room to put more numbers in between, but there are no numbers between 2 and 3. So that means I'm finished. So I start from the outside, I work in, and I'm finished when I get to 2 numbers that are right next to each other. Where's that colored chalk? Using red to underline the factors of 6, I want to show them. Here's 6. And then the factors of 6 are 1, 2, and 3. Because 1 times 6 gives 6, and 2 times 3 gives 6. 3 times 2 gives 6. I can do some fun things with my multiplication table that I've filled in. 1 times 6. Well, I really should say 1 times 6 is 6, and 6 times 1 is 6. I'm having a bit of fun here. It's just an excuse to use colored chalk, really. Let's do another one. Using a different color. How about, what was my other one? Factors of 12. Let's see if we can see the blue. Not so well, eh? So, 12, the factors of 12. Well, 1 is going to be a factor of 12 because 1 is a factor of every other number. The last one is 12. 12 is a bigger number than 6 and it might have more factors, so I'm going to leave more room. I'll put commas. Can I see that? This is why I don't use blue chalk. Okay, is 2 a factor of 12? Yes, because 2 times 6 gives 12. I'll just show the answer there. So yes, 2 is a factor of 12. And you get 2 to multiply to give 12 by multiplying it by 6. So that means 6 has to be the second last factor of 12. It jumped down by quite a bit. But the next one, is there another one? We have to try the next number. We didn't get 2 numbers that are right next to each other. So we try 3. Is 3 a factor of 12? Yes. Because 3 times 4 is 12. 3 times 4 is 12. There it is. When I see 12 as an answer in the times table, it's telling me something about the factors of that number. I can use the answer and then the numbers that multiply to give that answer to help me list my factors. And then 3 and 4 are right next to each other, so I just need a comma. I'm finished. I start at the outside, I always use 1 and the number itself, and then I try I try 2. And if it works, I include it. I may as well show one where 2 won't work, just so we have another example. And I am going to give up on the colored chalk right now and go back to the white chalk, and I'm going to try one last factor, one last number to find the factors of. So I'm going to try 15. Why am I holding this blue chalk? 15. 1 will be a factor of 15. 15 will be a factor of 15. Then I try 2, and it's not working. 15 is not an even number. So 2 is not a factor of 15. Then I try 3. And 3 works. 3 times 5 gives 15. So I need a 3 and I need a 5. And I can try 4. It's the only number left between 3 and 5. But 4 isn't going to work. 4 is not going to multiply by anything to get exactly 15. So I'm finished. I have a little bit of a space there, but that happens when I use this approach to list the factors of a number. The factors of a number is something that's easier to understand once you have become familiar with your multiplication table. The multiples of a number also. These concepts, factors and multiples, become very useful as we go into our fractions unit. And that's where I have to leave you because I have gotten to the end of the arithmetic review. It has been fun, as always, to teach the supercharged students a bit of supercharged math. I look forward to teaching you more in the future. And with that, I will say goodbye.